Right, let's just finish off this algebra nutshell then. So we've gone through algebraic terms, simplifying, substituting into them, dealing with brackets, whether it's getting rid of brackets or creating brackets with factorization. From there we moved to quadratics and we looked at how to factorize quadratics. Then we moved to equations. We went from single step to multi-step to inequalities to in context. Where we finished in class this morning was looking at formulas in context, where this particular question was dealing with a formula which had time, and we had to take 1 hour 15 and make sure that we weren't putting 1.15 for 1 hour 15, we were correctly turning it into a quarter of an hour. So we've got two little bits to finish. The first one on sequences. So a sequence is basically a list of numbers that is generated using a rule. So if we take this sequence, for example, at the lowest level, you might get a question which is just going to ask you to write down the next two numbers in the list. Or you might get a question which asks you to explain what's happening to the numbers, why the next number is what you're going to work out to be. So we can see here that this is going up in sixes. So 4 add 6 is 10, 10 add 6 is 16. So the next number would be 28. And the rule you would explain would be you would add 6 to the previous number. But what's more likely to be on an intermediate tier paper is what's called an nth term rule. And what an nth term rule does is, rather than use a rule to take the previous number to generate the next number, which is fine if you're on in a short list, but if I wanted to work out what the 100th number in this sequence is going to be, in order to work out the 100th number, I'd have to list 99 in order to find out what to add 6 to. So a more efficient method is called a position to term rule, or nth term rule. I know that the first number in this sequence is 4, the second number is 10, the third is 16, and so on. So I want to find a rule that's going to take its position, just take that number, do something to it to get 10, and that would work in the same way to the number 3 to generate the number 16. That's what the nth term rule is. And the way that you find that is, first of all, work out what the differences are. So you can see that here we're going up in sixes. That means it's a 6n rule. To all intents and purposes, it's the 6 times table. But instead of going 1 6 is 6, 2 6 is 12, it's been moved. And in this case, it's been moved down 2 places. So in order to work out what you have to do to that 6n rule to make it fit, you then look at the difference between what your differences are and the first term. So in order to go from 6 to 4, I have to subtract 2. And then that rule will work all the way. So for the second term, I'm going to do 6 times 2 is 12, take away 2 is 10. 6 times 3 is 18, take away 2 is 16. 6 times 4 is 22, take away 2, 6 times 4 is 24, take away 2 is 22. So the nth term rule for that sequence of numbers is 6n minus 2. So if they ask you to find an nth term rule, that's exactly what you do. You look for the common difference, whatever that is. So if the differences were 5, it would be a 5n rule. If the differences were minus 3, it was going down by 3 every time, it would be a minus 3n rule. And then to work out the shift, the extra bit, you look at the difference between the first term and you look at the difference between what it's changing by and the first term. So I've got to go from 6 to 4, so I have to take off 2. So that's how you work out what the rule is. You might be given the rule. So the alternative to that is a question like this. Write down the first 3 terms of the sequence 5n minus 4. So this is going to give you, it's going to generate the rule for you. So the first term n will be 1. The first position, the first term will have a value of 1. So rather than writing n, we write 1. When I replace a letter with a number, I've got to put the arithmetic times in there. Take away 4. 5 times 1 is 5, take away 4 is 1. The second term will be 5 times 2 now. I want the second term, so n is 2, take away 4. 5 2s are 10, take away 4 is 6. And then the third term will be 5 times 3, because I'm looking for the third number in the sequence. Take away 4, 15 take away 4 is 11. They may ask you for like the 100th. Well, the 100th term would be 5 times 100 is 500, take away 4, 496, and so on. So you need to be able to work out an nth term rule if they give you the sequence, but you also need to use an nth term rule to generate a sequence. And then the other way they could give you a sequences question is give it in a context, give you a spatial situation often where you are working with patterns. So patterns made with black and white circles are shown below. So pattern 1 has got a central black surrounded by 3 white. Pattern 2 changes. It takes pattern 1 and then it puts those extras on there, and so on. Complete the following statements in terms of n. So I'm looking for the nth pattern. There will be blank black circles in pattern n. Well, in pattern 1 there's 1, in pattern 2 there's 2, in 3 there's 3, in 4 there's 4, in 10 there's 10, in n there's n. So whatever the pattern number is, that will also give you the number of black circles. So in the 100th pattern, you know there are going to be 100 black circles. And then to figure out the white circles, we're now dealing with what we've got here, which is 3 white circles, 2, 4, 5 white circles, 2, 4, 6, 7 white circles. So it's generating a sequence like that where I've got 3, 5, 7. So the next one will be 9 and so on. I can see they're going up in 2s. So it's going to be a 2n rule. And to get from the difference to the starting one, I have to add 1 this time. So it's going to be 2n plus 1. So pattern 3 would be 2 3s are 6 plus 1 is 7. 1, 2, 3, 4, 5, 6, 7. Pattern 100 would have 100 black and it would have 201 white. So those are sequences. The very final algebra that we need to refresh our memory on then are with the U-shaped graphs. So we're taking a quadratic expression, just like that one there, x squared, x and a number, and we're using that to look at what it would look like plotted on a graph where the x is the x coordinate, and by putting values of x in there you calculate the corresponding y coordinate. Now when we practice these in class, the first thing I suggested you do is, even though we've got 2 gaps there, before we work those out, we'll plot the points that we're already given, because they'll help us have a sense for roughly where those are going to be. So x coordinate of -2, y coordinate of 17. So if we look at this, obviously I've shrunk it down a lot to fit on the page, but we need to make sure that we've got our squares right. And what we've got there is 0 to 5 in 10 jumps. So each little square is a half. So minus 2 is here. 17 is going to be another 4 little squares up from that, which is there. And it's important that you plot these accurately. 0 is negative 1. So negative 1 is going to be 2 squares down from there. 1, we're going to cross 1 and down 4. We don't know the 2 yet. 3 is 2. And 4 is 11. Now I know from revising this then that a U-shaped graph is either going to be a smiley face or a sad face. I can't remember a GCSE paper where it was one of those. So it's almost certainly going to be a smooth U. So my points are going to come down there and rise back up there. So my negative 1, I'm looking for probably something between 0 and 5 maybe. So if I end up with an answer of 16, I know I've gone wrong. So in order to work out what the y coordinate is, I've got to replace the x in this expression with minus 1. And when we were practicing this, what I was saying is if you imagine you have the x and you smash it open, then it moves, flies through the air and lands. So rather than having the x that way round, it lands that way round to create a pair of brackets. So when you're smashing the x open, you end up with this. So I've taken the x, I got the 2x squared, I've replaced the x with a negative 1. Then I've got minus 5 and I've smashed that open again, and then I've got the take 1 which is left on there anyway. When you're squaring something, you're multiplying it by itself. So when you're doing minus 1 times minus 1, minus times a minus is a plus, the signs are the same, the answer is positive. 1 times 1 is 1, so that becomes 1. So I've got 2 times 1. Here, minus times a minus is a plus, 5 times 1, take away 1. 2 times 1 is 2, add 5, take 1. 2 add 5 is 7, take away 1 is 6. So that value there is 6. So when x is negative 1, y is 6. And that fits in exactly where I'm expecting it to see. If that would create in my curve a sort of hump, like, so if you ended up with something like that, then clearly it's wrong. So that's that missing value. I have to do the same now to work out if x is 2. So if I create a little bit of space for myself, so now y will be 2 bracket 2 squared, take away 5 times 2, take away 1. So this is an easier one to deal with because we're not working with negative values. So 2 squared is 4. 4 times 2 is 8. 5 times 2 is 10. And I've got a negative times a plus. The signs are different. The answer is negative. Take away 1. So go through that again. 2 squared is 2 times 2, which is 4. 4 times 2 is 8. 5 times 2 is 10. Negative. Take away 1. That doesn't change because we're not multiplying it by anything. So on my number line, I'm going 8 take away 10 is negative 2. Take away another 1, negative 3. So that one on my number line is going to go, that's 2.5 there. Make sure you plot your points so that they're clear to see and the center of that the cross is accurate. What we then have to do is draw a smooth curve through that. And if you remember when we practiced these, I told you that it's easier to turn your graph paper around so that your wrist is on the inside, because your wrist is like a natural curve generator. Okay? So you don't draw these with a ruler, you draw them freehand using a pencil. Just missed with that last one, so that's why you need a pencil. I'd rub that out and I'd start again, and there we are. So that's what your graph should look like. As I said, if you find that you end up with a lump in it, then one of those coordinates that you've added is going to be wrong. So for that, you would get a mark for correctly working those out. You get a P mark if you've plotted the points correctly, and then a C mark, curve mark, for drawing the curve. And then you may well get a final part which says draw the line y equals 5 on the graph and write down the values of x where the line cuts the curve. So if I just get myself another colour, the line y equals 5 goes through the y coordinate 5. So the y coordinate 5 is that one there. We'll talk more about those when we do reflections and things in geometry. So that's the line y equals 5. Because wherever you are on that line, the y coordinate will be 5. They then want you to write down what the x coordinates are for those points there. So that x coordinate there will be minus 0.9 probably, and this one here will be 3.4. And that's what you need to do. Okay, so that's a really easy thing to practice. We did that, I can't remember when we did that, I think possibly after we came back to school. So that is something that you should have in your folder rather than online. Okay, so that then covers all of the, oh, don't know why I can't zoom out. That's just because I'm recording. So that's all the work that you need to get your head around for the algebra assessments. So do your best. I'll go and scan this and put it on the classroom as well as this little video to finish it off, and then I'll start working on the revision paper for you too.